Hello everyone. In this section, what we'll be doing is we'll be looking at one question. It's a question we've seen before, but we'll be looking at it in its entirety because this is the first time we're going to go through a problem from complete beginning to the complete ending. We're going to formulate the problem, not really because we've done it a couple times. Then we're going to graph it. And I'm going to take you step by step through the graphing process. Following that, we're going to then completely solve the problem, consider our optimal production choices or optimal points, and solve to determine which of our three optimal points is actually optimal. However, before we begin, I'd like to quickly point out that next Thursday, not this Thursday, next Thursday, will be our midterm exam review. And our midterm exam will fall 2 weeks later. I will give more information during the review, but it will be 2 weeks later. So for now, let's begin. This is, as I said before, a question we've seen again and again. But the key point here is we're going to solve it from start to finish. Please pay careful attention because today you will also get your first major homework assignment, and it will be closely connected to what we are about to do now. Here we go. To begin, we're looking at the Beaver Creek Company problem again. And again, it is something we've seen again and again. But the reason we're focusing on it, as I said, is because we are introducing several new concepts. Because we're introducing new concepts, we don't want a new, unknown, potentially difficult problem to focus on. Instead, we want a problem that we've looked at before, that we understand well, and that we're very comfortable working through. So this is the Beaver Creek Pottery Company. To quickly review, they make two products, clay bowls and clay mugs. Those products are special because they're decorated with Native American designs and colors. They use two primary resources, special pottery clay and skilled labor. Given their limited resources, the company wants to know how many bowls and mugs they should produce each day in order to maximize profit. So, what we are attempting to find is what is the perfect combination of bowls and mugs that will allow the Beaver Creek Pottery Company to profit at the highest possible level. That is the core question being asked. Everything we're doing, graphing, solving for unknown variables algebraically, all we are attempting to do is determine this key question. What exactly, or how many exactly bowls and mugs should we produce with our resources to profit at the highest possible level? So, let's go over here and we see that a bowl is 1 hour of labor, a mug is 4 hours of labor. A bowl is 4 pounds of clay, a mug is 3 pounds of clay per unit. A bowl generates $40 of profit and a mug generates $50 of profit. We have a total of 40 hours of labor and 120 pounds of clay available. Looking at this problem, we see mugs make more money. So that's probably the right choice. But mugs take more resources. So maybe bowls are the better choice. We're not clear yet. So what we're going to do is we're going to solve this problem. We're going to consider all of our production choices. And we're going to arrive at our best possible choice. That's what we're looking for. How many bowls and how many mugs? What are our best possible choices in those respects? Step 1, we collect everything, we format the problem, we change our natural language problem into the standardized format. Now, we don't have to do that right now because we've done this many, many times. This problem many times. So I've skipped several steps and we've arrived here. Maximize z equals 40x1 plus 50x2, subject to 1x1 plus 2x2 is less than or equal to 40. For C2, 4x1 plus 3x2 is less than or equal to 120. That is everything we've done so far. This is our properly formatted problem formulation. From here, we're going to now move into graphing like we did last time. I'm going to take you step by step through the graphing of this problem. And before we move on to any new scenarios for now. So, step 1, we draw the graph. Now, when you're drawing your graph, my advice is to always use a ruler. One of the reasons we graph, especially at these lower levels, is to proof our solutions, to give us an alternate way of guessing exactly if our answer is correct or not. Sometimes we don't know if it's correct. We don't know if we've made mistakes. The graph gives us an alternate way of checking if mistakes have been made. That's what it does for us. It gives us a place to check to ensure if or if not mistakes have been made. If you take your time and you draw a good graph and a large graph, then most likely when you proof your final concept or when you check your answers, it will give you a very solid indicator if you are correct or not. So what I've done here is I've drawn a graph. No marks, no nothing yet, but I've indicated there are 20 lines on the x-axis and the y-axis. 20 notches here and 20 notches here again. That was randomly done. I don't know yet how many to draw. I'm guessing this should be enough. For most purposes, 20 notches on the y-axis here and 20 notches on the x-axis here should be enough. So let's move to step 2. In this, we indicate our decision variables. So I've written down here bowls on the bottom, and that's x1. And I've written over here mugs on the y-axis, and that's x2. Each point on this graph, so this point right here, this represents a production choice, a number of bowls, this amount of bowls, and a number of mugs, this amount of mugs. Each of these points right here represents this amount of mugs and this amount of bowls. What we are doing is looking at our production choices visually. It's giving us the opportunity to consider these situations in a visual manner. Once we've indicated our decision variables, then we're going to draw or write in the appropriate figures on the graph. In this situation, I chose 0 to 50 on the y-axis, 0 to 50 on the x-axis. And I'll show you in one moment why I chose those numbers. I don't know totally if that's correct, but when I show you in 1 minute, it seems like these numbers could be correct. I also want to make the graph as big as possible so it's easy to read. And so I've gone from 5 every 2 notches. Each notch represents 2.5. 5, 10, 15, 20, etc. 5, 10, 15, 20, etc. Once I've now drawn my graph, written in my decision variables, and put the appropriate figures on the graph, I now write in the constraints. So we have C1 is 1x1 plus 2x2 is less than or equal to 40, and C2, 4x1 plus 3x2 is less than or equal to 120. Now, as we saw in the last slide, I've chosen to go from 0 to 50 on both the x and the y axis. I can find, or I can determine approximately what these numbers should be by looking at the constraints. Very quickly, 40 divided by 1 is 40, 40 divided by 2 is 20, 120 divided by 4 is 30, 120 divided by 3 is 40. So the largest number among these two constraints was 40. That means on the y-axis and the x-axis, as high as we need to go is 40. That's how I knew 50 was a good number. Anything above 40 won't be used, but it doesn't hurt us to go a couple numbers higher. Okay, so we've written in the constraints. Now we have to move to the next step. And again, these are all steps that we've seen before. But it is nice to review to make sure everybody's following along together. So next, step 5, we want to determine our value for x1. And that I've done down here. Taking constraint number 1, 1x1 plus 2x2 is less than or equal to 40. I have let x2 equal 0. So I have 1x1 plus 2x2 less than or equal to 40. I replace x2 with 0. So I have 1x1 plus 2 times 0 less than or equal to 40. 2 times 0 is 0. So I have 1x1 is less than or equal to 40. I divide 40 by 1. x1 is equal to 40. So where x2 is 0 right here, x1 is 40 right here. And I've indicated that with this black dot. That's how I found the first coordinate for constraint line 1. Moving on, after I've found the value for x1, I repeat that process and I find the value for x2. And I've done that here. 1x1 plus 2x2 is less than or equal to 40. Let x1 is equal to 0. So 1 times 0 is 0. 2x2 is less than or equal to 40. 2x2 is less than or equal to 40. x2 we divide by 2. So 40 divided by 2. x2 is equal to 20. So where x1 is 0 right here, x2 is equal to 20. And I've indicated that with this dot right here. So now I have on constraint line 1, I have 2 points. I have this point and I have this point. The next step is connecting them. Connect those values to form constraint line number 1. That's what I've done here. I took my 2 points right here, 0, 20, and 40, 0, and I've connected them to give us constraint line 1. This line, constraint 1, if we remember, represents labor. So this line represents all of the production choices where labor is fully used. If I manufacture 20 mugs and 0 bowls, this choice right here, I'm fully using all of my labor. If I manufacture 5 bowls and 17.5 mugs right here, I'm still using all of my labor. If I manufacture 20 bowls right here and 10 mugs, I'm still using all of my labor. Any production choice on this line represents where we are fully using labor. Now, we're going to repeat this process one more time for constraint line 2. And I've done that here. First, 4x1 plus 3x2 is less than or equal to 120. I make x2 equal to 0, so 4x1 plus 3 times 0 less than or equal to 120. 3 times 0 is 0, so 4x1 is less than or equal to 120. x1 is less than or equal to 120 divided by 4. x1 equals 30. So we come over here, and where x2 equals 0, because let x2 equals 0, x1 is equal to 30. And I've drawn that line, that dot right here. Then, in this section, we're going to let x1 equal 0. 4x1 plus 3x2 is less than or equal to 120. 4 times 0 plus 3x2 is less than or equal to 120. 3x2 is less than or equal to 120. x2 is less than or equal to 120 divided by 3. x2 equals 40. So where x1 equal to 0, right here, x2 in that case is 40. And I've indicated that with this dot here. So we have 2 more dots. The next step is drawing in the line that connects these 2 dots. So this line represents all the places where clay is fully used. The first line represented all the places where labor was fully used. The second line represented all the places where clay was fully used. Once we've drawn these 2 lines, because we had 2 constraints, we require 2 lines. We have 2 lines, we move to the next step, and this is where we indicate what the different areas represent. In this situation here, we have enough clay because it's below C2, but we don't have enough labor because it's above C1. So these choices aren't possible because even though we have enough clay, we don't have enough labor. Down here, it's similar, but the opposite. We have enough labor because it's below the labor line, C1. But we don't have enough clay because it's above the clay line, C2. So these choices too are impossible. We see, because it's a maximization, we have these are our possible choices down here. We have enough labor because it's below our labor line, and we have enough clay because it's below our clay line. So all of these choices are possible. We can make 0 bowls and 20 mugs because it's below both lines. We can make 5 bowls and 5 mugs because it's below both lines. We can make 15 bowls and 10 mugs because this is below both lines. However, mathematically, we know that our optimal choices are always 3, in this situation, 3 possibilities. It is here, where C1 intersects the y-axis, here, where C2 intercepts the x-axis, or here, where C1 and C2 intersect each other. So, step 11 is where we indicate the possible optimal production choices or points. And I've done that here. This is our first possible optimal production choice, 0 bowls, 20 mugs. This is our third possible optimal choice, 30 bowls and 0 mugs. Or here, which is a combination of bowls and mugs, but we don't yet know exactly how many this is. It looks like maybe 24, maybe 7.5. We're not sure. So it looks like 24, 7.5, but we don't know exactly. So we move to step number 12, which is solving for one of the missing coordinates or production choices. That's what we're doing now. And what we've done here is, and I'll explain it, is attempting to solve algebraically for our missing coordinates or production choices. First, we consider both constraints. 1x1 plus 2x2 equals 40. 4x1 plus 3x2 equals 120. Now from this, I need to eliminate x1 or x2 by subtracting. I need to subtract here or subtract here and eliminate x1 or x2. 1 minus 4 doesn't eliminate anything. 2 minus 3 doesn't eliminate anything. So what I have to do is algebraically transform one of these two equations. I have to transform by multiplying every aspect of the equation by something. We equalize the equations by multiplying one or two of the equations to eliminate one variable. In this situation, what I did was I multiplied equation number 1, 1x1 plus 2x2 equals 40, by 4. I multiplied this aspect, and this aspect of the equation by 4. That's what I've done here. 4 times 1 is 4x1. 4 times 2x2 is 8x2. 4 times 40 is 160. Now I subtract. 4x1 minus 4x1 is 0. 8x1 minus 3x2, 8x2 minus 3x2 is 5x2. 160 minus 120 is 40. So x2, 5x2 equals 40. x2 equals 40 divided by 5. x2 equals 8. So I have solved, and I know this coordinate now. x2, the number of bowls, is equal to 8. We guessed 7.5 from our picture. The actual answer is 8. So one of our optimal choices will be producing 8 bowls. Next, we go to step 13. Next, when we've found one coordinate, as we did here, 8, we have to plug that coordinate into a constraint equation to find the other coordinate. And we see that information here. Once x1 or x2 is found, that value is inputted into a constraint, and we solve for the second variable. So I took constraint number 1, right here, C1, 1x1 plus 2x2 equals 40. I substituted x2 for 8, so we have 1x1 plus 2 times 8 equals 40. 1x1 equals 40 minus 16, which is 2 times 8. And we get 1x1 equals 24. x1 is equal to 24. So our B optimal choice that we had here, we now know is 24, 8, which means the third possible optimal choice is 24 bowls and 8 mugs. So what that means is, very simply, our three possible perfect choices are manufacturing no bowls and 20 mugs. Manufacturing 24 bowls and 8 mugs. Or manufacturing 30 bowls and 0 mugs. These are the three possible choices that could give us our maximum profit. So step 14, once we have our three possible choices, and I've written them here, is we're going to indicate those three possible optimal choices that I just did. 0, 20, 24, 8, 30, 0. Once we have these three possible choices, and this is a step you should follow, then we go in step 15. We run these possible optimal choices through the objective function to determine profit at each production choice. And I've done that here. We take these three optimal choices and we multiply by the values given to us in our objective function. So we come over here. If we manufacture point A, which is 0 bowls and 20 mugs, we get 0 times 40 plus 20 times 50 equals $1,000 profit. If we manufacture 24 bowls and 8 mugs, we get 24 times 40 plus 8 times 50 equals $1,360 profit. If we manufacture only 30 bowls, we get 30 times 40 plus 0 times 50 equals $1,200. We consider these three numbers and we see our best possible choice is production choice B. Manufacturing 24 bowls and 8 mugs. If we pursue that course of action, we get $1,360 in profit. That is our optimal choice. Optimal production choice. That is how much we should produce of each product in order to maximize our profit. Then the final step, we indicate in natural language the actual optimal production choice that delivers the greatest profit. So we indicate our optimal production choice like I've done here and state the final answer in natural language like I've done here. Our optimal choice is to manufacture 24 bowls and 8 mugs to generate $1,360 in profit. That is everything I've done so far. That is a complete solution of a 2 constraint, 2 decision variable, linear programming maximization problem. We will in the future look at more complex problems, but for now, this is your first view of a start to finish complete solution to a problem like this. This will be critical moving forward. Again and again and again, we will look at problems like this. This is something we will see repeatedly. If you are unclear at this stage, if you are unsure of anything, you are very quickly running out of time to ask me for help. Our midterm exam is coming in 2 weeks. Our midterm exam will have complete solution problems. If you are unclear of what I did today or what I've done in the past, you're very quickly running out of time to ask me for help. So hopefully everybody is clear. If you are unclear, hopefully you're willing to come to me for help. If you would, please contact me through Kakao for questions or solutions of things we have done in the past. Now, we are going to conclude today because what you have now is the first half of homework assignment number 1. In this class, as I said, you have 2 homework assignments. One before the midterm exam, one after the midterm exam. Homework assignment 1 is a 2-part question. Today you will get part number 1. In the next session, you will get part number 2. Homework assignment number 1 is a 2-person team project. 3 people is not okay. 1 person is okay. Listen very carefully to these instructions because you will lose points if you do not follow these instructions. This is a video. You can check the video if you are unsure about these instructions in the future as well. So one more time, it is a 2-person team project. The project will be due before the first class next week. Before our first class next week. I will send you a Kakao message and remind you, but it will be due before our first class next week. It is 15% of your final grade. There will be 2 sections. This is section 1 that I will give you today. Section 2 I will give you next class. Section 1 is 5%. Section 2 is 10%. For section 1, you will look at the question I will show you next on the next slide, and you will solve it exactly as I've solved this problem here. You will follow each and every step. Handwriting is okay, but you must write well. Take your time, write well, write clearly. If I cannot read your answers, you will lose points. Your graph should be drawn on lined paper with a ruler. If you do not use a ruler, you will lose points. If your graph is not well drawn, you will lose points. You can see here how neat and orderly my image is. Yours should look the same. There are no excuses for a sloppy homework assignment. I am allowing you to handwrite this because it is easier than using the computer. However, if you do not do it well, you will lose points. I expect a clear, easy to follow image that has each and every step in your image that I have indicated here. If your image is missing steps, you lose points. If your image is unclear, you lose points. If your graph is unclear, you lose points. If your graph was not drawn with a ruler, you lose points. If these key areas, optimal choices, missing variables, optimal solution, natural language, final solution, if these key areas are not highlighted, you lose points. I have given you right here a perfect template to follow. Your page should look almost identical to what we are looking at now. The only major differences will be because you have different numbers in a new question. Everything else should look almost identical to this. If there are questions about this, please contact me through Kakao. Now, your solution will be slightly different because the problem is not a maximization, it is a minimization. The major difference between a maximization and a minimization, number one, you should know because we have covered it together in class. But the major difference is in a minimization, the key points, the key possible places are not below both lines. They are above both lines here. In a maximization, if you have enough of one and not enough of the other, it will be here. These will be impossible because you'll have not enough of one or the other. And this will be enough of one but not the other. This area over here will represent your possible optimal choices. Your possible optimal choices will be A, B, or C in a minimization problem. So again, that is the only hint I'm going to give you. This is part 1 of your homework project. Part 2 I will give you in our next session. In part 2, it will be similar, but we will have additional constraints. So for now, before our next session, I recommend completing part 1, 5% of your final homework project. That will be very similar but not identical to what I've done here today. If there are no further questions, and again, if you do have them, contact me. Here is your homework problem. It is the pizza problem. We have done this before together. You own a pizza restaurant and you've just received an order for 100 pizzas for tomorrow. This problem we have looked at together. We have formulated together. So this should theoretically be relatively easy for you. You are going to A, formulate the problem, B, graph the problem fully and completely, and C, solve the problem like I did in the example question. Thank you, everybody, for listening. This is the end of today's session. Have a wonderful day. If you have questions, please contact me.